Okay, so today we'll be doing triangles. Okay, what are triangles? These are polygons that has three sides with three sides. Okay, so before this we had lessons on quadrilaterals, and quadrilaterals are figures or polygons that have four sides. Okay, now triangles now have three sides. Okay, so this is an example of a triangle. This one as well, and this one, and this one. So any three-sided polygon is a triangle. Okay, so let's look at the types of triangles according to the length of the sides. Okay, so we have two kinds of classification of triangles. One is according to sides, and the next one is according to angles. So for this one here, we'll be doing the types of triangles according to size. So the first one is scalene. It means no equal sides. Okay, so as you can see, this triangle has three sides and not a single side is equal to the other. Okay, alright, so that one is another example. So all sides are of different length. Okay, so the next one is called isosceles triangle, where two sides are equal. Okay, so as you know, triangles have three sides, and out of the three sides, two of those are equal. Okay, so this is an example. Okay, right? So as you can see, you have those single bars in there, which means those two sides, the two red sides are equal in length. On the second one, you can see that the two yellow sides are also equal in length. Alright, so the third one is called equilateral triangle, where all sides are equal. Okay, so this is an example of that. Okay, so again, according to sides or according to the length of the sides, we have scalene, we have isosceles, and equilateral. Okay, so I would really like you to memorize that and be able to define these kinds of triangles. Okay. Okay, so let's try this one. So let's say this triangle here, ABC, one side, side CB or side BC is 8 units, and the other two sides are equal. Okay, that means the single bar, that means both sides with single bars are equal in length. So therefore, side AC is equal to side AB. Okay, say assuming AC is 10 feet, what would AB be? Okay, since they are equal, AB should also be 10 feet. Okay, alright, there you go. Alright, so let's learn this name perimeter, this word perimeter. Okay, what is perimeter? It's the sum of the lengths of all sides of all polygons. So it's not just for triangle, it's all types of polygons. If you add all sides, the sum of that is called a perimeter. Okay, so the perimeter of this triangle would be, if you would add AB plus BC plus CA, which is 10 plus 8. Okay, alright, so let's try this triangle. So we have this triangle ABC again, and that is 12. And there you go, that notation again, which means all sides are equal. Okay, so therefore, if all sides are equal, what kind of triangle is ABC? Okay, that is, because all sides are equal, that means it is an equilateral triangle. Alright, if AC is 12 units, what is the length of AB? Since again, all sides are equal, therefore AB should also be 12. Okay, and what is the length of BC? Again, that's also 12 because they're all equal. Okay, and the perimeter would be if you add all three sides. That is 12 plus 12 plus 12 equals 36, or you can also do 3 times 12 because all sides are equal. Alright, so let's try the next classification of triangles, which is according to the angle, the inside angles of the triangle. So the first one is called acute triangles, where all angles are less than 90 degrees. So how many angles does a triangle have? Okay, how many inside angles does a triangle have? Since it has three vertices, therefore it also has three angles, and all these angles should be less than 90 degrees. If you remember our lessons about angles, all angles that are less than 90 degrees are called acute angles. It's the same thing with triangle. If all the angles of a triangle are less than 90 degrees, then that is an acute triangle. Okay, this is an example of that. So all angles would be less than 90 degrees. The next one is called obtuse triangle, where one angle has more than 90 degrees. Only one angle. You cannot have two obtuse angles or two angles that are more than 90 degrees because our triangle will not close. Okay, so this is an example, and that is the one that has more than 90 degrees. Okay, and the third one is called right triangle, where one angle is equal to 90 degrees. Alright, so let's go through this again. So the types of triangle according to angles. Acute triangle, all angles are equal to is less than 90 degrees. Second one is obtuse triangle, one angle is more than 90 degrees. And the right triangle, where one angle is equal to 90 degrees. Okay. Alright, so let's look at this graph, this figure. Okay, so this is a series of triangles. So let's look at the notations. We have equal sides, and the first two sides are equal. AF and FB are equal. And also in the lower side, we have EC, CD, and DE as equal sides. Okay. Alright. Okay, so which triangle do you think is scalene? Meaning all sides are not, no single side is equal. Okay, so I'm pretty sure we could find a number of a scalene triangle here, but let's pick one. So you can see that triangle FBC, because FB is not equal to BC, it's not equal to FC. So that's an example of a scalene triangle. Okay, how about an example of isosceles triangle? Again, isosceles has two equal sides. So which triangle here has two equal sides? Okay, so the topmost triangle, which is triangle ABF, because AF is equal to BF. Okay, that part there. How about an equilateral triangle? Okay, so for equilateral triangle, we can look at the bottom part, which is ECD, where all sides are equal. Okay. Right, so looking at the triangle again, right triangle. Okay, which one has a right triangle? So right triangle is the one that has a right angle. Okay, so that would be EFC, where angle E is a right angle. Okay. Right, what is the length of FB? Let's go back up. FB is equal to FA, and FA is 5. Therefore, FB is also equal to 5. Okay. Alright, what is the length of CD? CD, as you can see, is equal to EC, and EC is equal to 8. So, therefore, CD is also equal to 8. Okay, and what is the length of ED? Again, ED is equal to EC, and that should also be 8. Okay. Alright, so what is the perimeter of ECD? Okay, ECD, so this is an equilateral triangle, so that is 8 plus 8 plus 8. Alright, so that is 24 centimeters. Okay, I hope you work on your assignment for today, and let's not forget these lessons because we'll be having a long Christmas break, and good luck with your assignment on Friday. We'll be working some test works on, tomorrow.